don't even watch Game of Thrones.
All right, so for pyramids and cones, they're hard to look at, right? Because there's a lot of different stuff in a lot of different areas. So a pyramid, we're going to use 1/2 P L plus B. What? So it's 1/2 times the perimeter of the base, and you have to know how to name the shape to be able to identify what the perimeter of the base is, because if it's a triangular pyramid, there's a triangle base. If it's a trapezoidal pyramid, it's got a trapezoid base. And then L, cursive L. No. The slanted height. All right. So, if I'm talking about L, L is the length on the face. It is the length of the face from the apex to the side. Slanted height. It is not the vertical height. Look right here. Vertical height is perpendicular from apex to base like this. Slanted height is a slanted height. It's the length on the face. So in this picture, your L is on the face right here. The height is inside the shape from the base to the vertex. Kind of the same thing for a cone. It's pi r squared, that's area of the base, plus pi r L, and that is the slanted height L on the face of the cone. So these two have those very specific things. A slanted height is really only used for pyramids and cones when calculating surface area. So these pictures are meant to be kind of visually confusing, so we can work through it today. Let's see, a regular pyramid, a pyramid whose base is a blank. If it's a regular pyramid, the slant height is the length of the blank of the lateral face. Oof, man. So the slanted height is the length of the height of the lateral face. So that's looking at the length from here to here. If you look at just this flat triangle, it's the height of this triangle. Now remember that a height and a slant height are not the same. We've kind of talked about all this other stuff. So let's get into it here. What do you call that? It's a triangular pyramid. Because it's a triangular pyramid, a triangle is the shape of the base. So if we're using that the surface area is 1/2 the perimeter of the base times the slanted height plus the area of the base, what is the perimeter of the base? 8 plus 8 plus 8. Perimeter of the base. The distance around the base. Perimeter. So 8 plus 8 plus 8 is 24. Times the slanted height. So remember, your slanted height is the distance on the face. What's the slanted height here? 10.3. Plus the area of the base. So I have to find the area of this triangle. How do you find the area of the triangle? 1/2 times the base times the height. So all the information is there. Here's your base right here, 8. And here's the height of this triangle right here, 6.9. So you use your calculator, you can type all that stuff in. Let me get mine loaded up and we'll find an answer. So we'll do 1/2 times 24 times 10.3 plus 1/2 times 8 times 6.9. Yeah? It gives you a total surface area of 151.2. You get something different? You on your phone or so this is me taking the information from here, 0.5 times 24 times 10.3 plus 0.5 times 8 times 6.9, and you get 151.2 meters squared. So it's a lot of plug and chug. Use the formula, find the information, plug it into your calculator, and you get an answer. Let's see what else we got here. Oh. What do you call this guy? A square pyramid. So the area or the shape of the base is a square. So as we use our formula, the surface area is equal to 1/2 the perimeter of the base . 7 plus 7 plus 7 plus 7. 28. Times the slanted height. So that's this part of the formula. 1/2 plus PL. Then we have to add to that the area of the shape of the base. How do you find the area of a square? Length times width, base times height, 7 times 7 is 49. So it's 1/2 times 28 times 8.7 plus 49. 1/2 times 28 times 8.7. And we add to that the area of the base, 49, and we get 170.8. That is the total surface area of that square pyramid. I already forgot what it was. 170. How do you feel? Plug and chug, plug and chug, plug and chug. Put the right information in the right spot. Alright, what do they call this guy? It's a rectangular pyramid. Alright? Now, does this one look confusing?
Because it has two
It has two slanted heights. So what are you supposed to do?
Use one. Add it again.
No. You think we'll get the same answer if we do it both ways?
No.
We're gonna try and find out. Let's see what happens. So we'll do one answer in pink here. 1/2 times the perimeter of the base, 9 plus 9 plus 8 plus 8, that's 18 plus 16, 34. Times the slanted height. Which one do you want to use?
Use the smallest.
We try 11.7 first.
Sure.
Plus the area of the base.
What did you guess in?
9 times 8. That's area of the base. We're gonna get two different answers, pretty sure. 1/2 times. Huh? 11.7
Yeah, that's the first one.
plus 72,
Yes.
or 1/2 times 34 times. So what are we supposed? Huh? I feel like one of those is not correct. Tis confusion. I know what you're supposed to do, but what's the issue here?
Just choose one.
No. We do get two different answers. This one comes back as 270.9. And this one comes back as 274.3. Neither of which is correct. So what are we supposed to do? No. So here in this scenario, we're gonna have to kind of solve for what is the area of this triangle right here. 1/2 times the base times the height. So that's this face right here. And that base back there. Those two are the same triangles. So let's do that real quick. 0.5 times 8 times 11.9. That's the area of one face, and we have two of those faces, so we add them together. So the area of the blue faces is 95.2. Then we can find the area of the red faces, which is this triangle right here, which is 9 times 11.7, or 1/2 times 9 times 11.7. And there's two of those, which is 105.3. So we have two red faces and two blue faces, and then one black base. The base down here is 9 times 8, which is 72. So we add all those numbers together, 105.3, 95.2, and 72. 272.5. Did it work? So right smack dab in the middle. Why did it not work there? Why did our surface area not work? Because we have two different slanted heights. It's not a regular pyramid, it's a rectangular pyramid, so the shape of the face is different. That's one of those hard examples. Hopefully there's not any more of these. Okay, so now if you look at this one, it's a regular pentagon. So that means every face, 1, 2, 3, 4, every 5 faces is the exact same size. So we don't have to go back and find the area of each individual face and add them together. The perimeter of the base is 10, 10, 10, 10, and 10. We have 5 links that are 10 units long. So the perimeter of the base is 50. And then the slanted height is the same on all 5 faces, 10.6. And we have to add to that the area of the base. How do you find the area of a pentagon? There you go. 1/2 the apothem times the perimeter. For any regular polygon, it's 1/2 the apothem times the perimeter. The apothem is the length from here to here, which is 6.9, times the perimeter of that regular pentagon, 50. So we do 1/2 times 50 times 10.6, and we add to it 1/2 times 6.9 times 50. We get the total surface area of that shape. $437.5. So we do 1/2 PL plus B, and that big B turns into 1/2 the apothem times the perimeter. Plug and chug all this information right here to get 437.5. So all the information's there. Put the right stuff in the right spot. Alright, so last section here, cones. Remember with cylinders, when the base was a circle, it became a little easier. We only have 2 pieces of information to plug in. So the surface area of a cone is pi r squared plus pi rl. What's your radius? 5 miles apparently. So pi r squared plus pi, what's your radius? And then the slanted height. So pi r squared plus pi rl. The slanted height is this length right here, 13. Pi r squared plus pi rl. Let's type that in. Pi 5 squared plus pi 5 times 13, and we get 282.74. So that cone is 282 square miles. It's a big cone. Huge cone. So again, I think this information is a little easier to see, a little easier to plug in because it's just a cone. You don't have to change the shape of the base. Watch out for these tricky ones.
I can start my quiz now. Would you prefer me to come in later?
So let's look at this one. What's the only way I'm trying to trick you on this one?
There's a diameter.
It gives you a diameter instead of a radius. So if the diameter is 16, what's the radius? Pi r squared plus pi r L. Pi r squared plus pi r L. Type it in and see what we get. Was it 17.9?
Yes.
650.94. Lots of just calculator work. You know how that's how it's going to be pretty much the rest of the unit. All right, same thing here. Pretty straightforward problem. And then here's the last one I want to talk about. Do we have all the information here?
I'm gonna select
No. Do we have a slanted height? No. We don't even have a radius either. So we have a diameter from here to here is 16, but how far is it from here to here? 8. You know that this is 16, but we need to find that length right there. So we have to do a squared plus b squared equals, bless you, oh sorry, a squared plus b squared equals c squared, and our c is the slanted height right now. So I'm going to use my calculator to do that because I'm feeling a little lazy today. 8 squared plus 16 squared is 320. And then to undo c squared, you take the square root. And that means that our slanted height is 17.9. Then it becomes the exact same problem we just worked on. Pi r squared plus pi r L. 650.93. Alright, lots of calculator work. The only way that this ever gets complicated and that we kind of stumbled through it together was when you see a problem that looks like this. And the main reason being that the base is not a regular polygon. It's a rectangular pyramid, so you have to find the area of each individual face. So because